this slope here, I go back 15, and I'm moving 15 in the positive direction over 1 second. That's a slope of positive 15. And then this last little bit, I move another 15 meters in the positive direction, but it takes me 2 seconds to do it. So that's 15 divided by 2, or a slope of positive 7.5. So each of my sections is identified by a length of time and a slope. And then to create a velocity versus time graph from that, I just need to make sure that I have a section on my velocity versus time graph with the slope of each time period. So my time periods on my velocity versus time graph are going to be broken up the same way as my position versus time. The information that I graph, the y-axis, is going to be the slope that I calculated here. Yeah?
Wouldn't it be negative 32?
Are you thinking this is 16?
Well, it
yes.
doesn't look like 50.
Yeah, and so absolutely is the answer. And if we were performing a task, and the task were, you got to know exactly how fast this thing is going at any time, you would be 100% right, and anybody who didn't identify that would be wrong. But if we think about it as a skill, the skill of being able to like take a position versus time graph and correctly figure out what the velocity versus time graph looks like, then thinking about this line right here, whether this is negative 16 or negative 15 is less important, right? Like if you were to say, I think that's negative 16, then we'd get a slightly different slope. But the skill of figuring out the slope and figuring out these sections is all the same, yeah. It's always better to do things right when you can. But to my eye, this just looks like whoever drew, I didn't make this graph. This to me just looks like whoever drew it just kind of missed a little bit. That I didn't think that that was negative 16. I think that was just somebody trying to make negative 15 and doing a bad job of it. So the time periods are going to be the same. I'm going to have part of my velocity versus time graph for 2 seconds. The next 2 seconds is going to be part of it. The next second and a half is going to be part of it. And then there's going to be part of it that's only a half second long. And then there's going to be part of it that's 2 seconds long. Then there's going to be part of it that's 1 second long. And the last part is going to be 2 seconds long. And these parts are going to have a velocity value, my y-axis, that corresponds to this slope. The first 2 seconds have a slope of 0 on my position versus time graph, which means the first 2 seconds have a velocity of 0 on my velocity versus time graph. The next 2 seconds have a slope of negative 5. Well, I got to figure out what my scale is here. I know I'm going to have a slope of negative 30. So in the negative direction, I got to be able to get to 30 over here. And my largest positive slope is 15. So I think probably what I'll do is I'll just go by 5s, because that gets me 15 here pretty easily, and it gets me negative 30 here pretty easily with plenty of room. So if I have a slope of negative 5 on my position graph, that corresponds to a velocity of negative 5 on my velocity graph. Then I'm back to 0 for a second and a half. And then I have my maximum negative slope of negative 30 on my velocity graph for a half second, so that's here. And then I'm back to 0. I'm at my maximum position, but down to 0 velocity. And then I go into positive velocities. For 1 second, I have a slope of 15 for my position graph, so that's a velocity of 15 on my velocity graph. And then for the last 2 seconds, my slope drops to 7.5, so my velocity drops to about 7.5. And it's a little hard to see how all those things are connected, and so by convention what we do with a graph like this is we just draw vertical lines to connect our sections. So you can sort of see how these things would sort of move from one to another. And one of the things that we'll talk about down the road is what do these vertical lines mean? What does that tell you about what's going on? And what it really tells you is that we don't really care what's happening there. We're not sure, we don't care. what that motion actually looks like almost certainly would not be depicted by a perfect vertical line. So this is our velocity versus time graph. This effectively tells us for each time period the slope of our position versus time graph. Okay. And I'm gonna stop there and let you all have some time to actually work on this stuff. I wanna just show you the assignment real quick. I'm gonna stop the video here.